Good morning.
Um, Good morning. Anybody there?
Good morning.
Good morning. Sorry about the late start, but we were having a little technical issue with this Zoom setup. So I'm just getting some instructions from Miguel.
Okay.
So we should begin in a minute or two. I had sent a video out to you all to watch before the lesson. So if you haven't watched it as yet, you could do that while we just complete this setup. Should take me another minute or two.
Okay.
Let's not share. Okay, can you all see the screen?
Yes.
Okay, all right then. Yeah. Yeah. Okay, I think we are ready to begin. Let me. Okay, let me see. I see Miss, is this Dominic Fernanda? Are you there?
Yes, I am. I'm here. Good morning.
Okay, Dominic, I just need to make sure. Okay, Dominic Fernanda.
Can you hear me?
Ms. Fernanda,
Hello?
were you able to watch the video that I sent?
No, I just was trying to catch up. I just actually saw the email.
Okay, all right. So from time to time in the week, I may send stuff, so I need to check your email. So just in case anything is sent, you can see before the class, because certain things we may need to do before the lesson. So we could maximize the time of the class with the
Okay.
content. Krishna Kemp, are you there? Okay, no. Fabienne La Rochelle,
Present.
present. Okay. Were you able to watch the video before the class?
I didn't get a video. I got the course schedule.
I also sent a link to a video. Okay, all right.
I'll just
Um,
course.
okay. Latonya Nairn, are you there?
I'm here.
Okay, just checking to see if you're able to see the video that I sent out.
I was just watching it.
Okay, all
Mhm.
right. Mr. Pickstock? Mr. Pickstock, are you there? I see you online here. Would you unmute Mr. Pickstock and respond? Okay, I guess Mr. Pickstock is not with us this morning. Miss, is this Irvinette Pratt?
Yeah,
Are you there? Okay. Were you able to watch the video before the class?
yes, I was.
Okay, that's good. Shantia Simon, are you there? No, okay. Okay, good morning to all of you. My name is Donald Allen. I will be your lecturer tutor for this course, Math 140. Sorry about the late start, but we were having a little issue with the Zoom setup. Miguel had several other classes going, so I had to more or less take control, and so he had to share the procedure for me to take control since he had several other classes going on at the same time. So hopefully next week we will start a little earlier. We have a lot to cover, so we cannot we can't afford to waste much time with this class. Okay, so this is Math 140, and I want to just begin with some tips that will help you to succeed in the class. And this is just based on the experience I've had. I've been teaching with BIFs now for a number of years. In fact, it could be around 10 years now, or maybe more. But one of the things I have to point out to persons is that, especially with this virtual situation, you need to attend all classes. Already I see 3 persons out. I don't see Miss Kim. Who is this now? Missing Miss Kim, Mr. Pickstock, and Miss Simon. So if you know them, I need you to let them know that they're expected to attend all classes. You have to devote time to attend the class. You shouldn't be driving while class is going on. You shouldn't be doing anything else. You need to set aside the time. You know it's going to be between 9 and 12. Set aside the time for the class. Okay? You should not be doing anything else but focusing on the lesson when it's time for class. And if you want to succeed, you have to invest that time and put the effort into making sure that you attend all the classes. Okay? Now, of course, there may be instances where you cannot or you may not be able to attend. So the classes, as far as I know, are being recorded. And so I think Miguel has a YouTube channel where he posts lectures. So I think I saw an email where he sent explaining to you how to access the recorded videos. Did you all see the email?
Yes.
Yes, I saw.
Yeah, okay. So if you have to miss a class, please try to at least access the video so you could see what happened for a lesson that you missed. Now, a book is, the book is called Thinking Mathematically, the 5th edition. I think Miss Dean said she has copies available in the office for sale. You are encouraged to get the book. If you don't have the book, I give some resources. I plan to give some resources. For example, I posted a video, I think it was yesterday. I sent it by email. You're encouraged to either read the book or whatever resources are provided. Please try to either read or view them, because that is only going to assist to make sure you get a better grasp of the concepts that we'll be covering. You're also asked to participate. So when I call on you, I expect a response. If you don't know the answer, just say you don't know, or you want to pass on it. But I would expect all of you to participate in the class. And if you don't understand something, please ask. Okay, you pay for the course, and part of your participation is to ask questions if you don't understand. Don't worry about other persons. You need to understand. Ask your questions. So please do that. Now, you are also asked to complete assignments. don't wait until the day before class to do your assignment. Each day, if you have 20 questions to do, well, you could decide, okay, I'm going to do 5 a day. You know, if you want to sit down and do all one time, no problem. But try to make sure not to wait until the last minute or the night before to do homework questions. You're going to get questions after every class. You're going to get homework to do. Please try to have the homework done in time for the next class. Now, I'm not going to be marking homework, but I'm going to ask you to show that you did it. So you could take a picture of it and email it to me, and then you will be credited for doing the homework. The answers are given to you when you have the homework. I give you the questions and I also give you the answers. So you're going to work the question, see if you get the answers that are there. If you don't get an answer and you can't figure out why you were not getting the answer, then in the next class, you could always bring it up for discussion and we could explain the procedure or what went wrong. Okay, I think I
Hi, I have a
mentioned this.
question, please.
Yes.
Will a WhatsApp group be formed or we'll send you assignments via email?
I prefer you to email it to me. So you could, now let's put it this way. I'm not going to form a WhatsApp group, but I have a phone number that I think I have on the course outline that I sent to you, 803-9975. If you want to, you could just take a picture of the homework and send it through WhatsApp. Yeah, but I'm not going to actually form a group. So if you WhatsApp a picture of the homework to me, that's good enough. Or if you want, you could take a picture of it and send it by email. So either way is good. Okay. Hello?
Yes, thank you.
Yeah. Okay. All right. So, all right. And then of course, we're going to have test quizzes. So you're encouraged also to make sure that you review every so often in preparation for tests and quizzes. So I'm going to look at the course outline now, which I sent to you. I think, yeah, I already sent that to you. So just want to quickly look at that. So today today is the 29th. We are going to be covering sections 2.1 and sections 2.2 of the text. At least that's what I'm hoping we can do. It's a lot, so we'll see how much we could cover, but the plan is to cover sections 2.1 and 2.2. So each week for the next 13 weeks, the outline is shown on this course outline. Next week, you get test number 1, and well, I should call it a quiz really. And it's just for half an hour or thereabouts. And each quiz is worth 2.5% of your overall score. And it will just cover what was done in the previous classes. So the quizzes are not going to be cumulative. It's just going to be covering the content in between each quiz. So for next week, you'll be covering what we did today in that quiz. And then the next quiz, which would be in the 4th lesson, will be covering what we did in lesson 2 and lesson 3 and so on. We have 2 midterms, and the midterms are each 20%. And you will have to go into the office to do the midterms. And so, yeah, so that would be the only time that you actually need to go into the BIFS. I think, yeah, to do the midterms. I don't think we're going to do that online, but the quizzes we can do virtually. Okay, so my name is there at the bottom, Donald Allen. The WhatsApp messages you could send, the numbers at the bottom, 803-9975, and then we have email, dokeal@gmail.com. Of course, the text is mentioned here, Thinking Mathematically, 5th edition, and suggested materials. Definitely a scientific calculator is recommended. Okay, and so on. The grading scheme is shown. Okay, So you need to maintain 60% or, well, is that, no, 55% or above to get grades ranging from A to C minus. Anything below 55 is a failing grade. So you need to maintain an average of 55 or above. And then you see the breakdown, homework, 10%. So every time you do the homework, I record it. Or if you do all the homework, once I see it, you get full marks. Once I see that you did it, and all homework, all 14 or 13 assignments will give you 10%. Your tests, if you get 100% on all 4, that's 10%. Your 2 midterms are 20% each. And then the final exam is 40%. So you can go into your final exam with a 60 if you get 100% straight through for your course component of this course. Okay. Final exam is slated for May 7th, and that will be at the BIFS office from 9 to 12 noon. Okay. So that is your course outline. Any questions regarding the course outline? No? Okay. Mr. Pickstock, are you here as yet? No? Okay. All right. So today the objectives are listed. We have 12 objectives, so it's quite a bit. And so we're going to see if we could get through as much of this as possible. Now, these topics, I think, once you went to high school, you should have covered most of this. It might be a little while ago, and after high school, maybe you might not have even used some of these concepts directly, even though in some cases you use the processes, the reasoning skills involved with some of this, but you might not use it directly. So we're going to move on. The video that I sent covered a good amount of the basic set concepts. So it starts off with what is a set? A collection of objects whose contents can be clearly determined. And I really like that video because she gave some good examples of what it means to be clearly determined. So if you haven't watched the video as yet, I suggest you do so.
Good morning, Mr. Allen. How are you?
Good morning. I'm good. Okay.
Great. My name is Joel Pickstock. Sorry for that. I couldn't speak at the moment. Wi-Fi kind of kicked me off Zoom, but I'm here, sir.
So this is Miss Pickstock or Mr. Pickstock?
Mr. Pickstock. Mr. Pickstock.
Oh, Mr. Pickstock. Okay.
Yes, sir.
All right. I can. Did you get a chance to watch the video, Mr. Pickstock?
No, sir.
Okay.
I literally didn't review the email till like yesterday evening.
All right. All right. So if you get a chance to, I suggest you do so. Well, not if you get it. I'm telling you to watch it. Not necessarily now, but at some later point. So it's not if you get a chance to. I want all of you to watch that video because it's
Yes.
very helpful to explain some of the concepts that we're
Yes,
going to be looking at today. All right. So
Thank you.
definition of the sets is shown here. A set of a collection of objects that can be clearly determined. The elements or members are the objects in a set. So we refer to the things within a set as elements or members of the set. A set must be well defined, okay? Meaning that its contents can be clearly determined. And so that's all the more reason why that video is important, because she gave some good examples of what it means to be well defined and clearly determined. Okay, and then the last concept here about concerning sets is that it says that the order in which the elements of the set are listed is not that important. It's actually what's in the set that we should be concerned with. Now, even though the order is not important, you're usually encouraged, like if you have a set of numbers, if I say, give me the set of the first 5 prime numbers, we usually encourage you to put them in order of size, but it's not, you wouldn't be marked down if you don't put them in order. but it's usually encouraged to put them in order. It makes it easier for persons who are assessing you to see if you have the right things, but it's not exactly necessary, okay, that you put things in order. Okay, so now in terms of representing sets, the method for representing sets, it says capital letters are generally used to name sets. Okay, so we name the sets using the capital letters. So you'll see here, in this case, we have set W, the set of days in the week. So even though we are looking at the set of days in the week, oftentimes when we are actually identifying a set, we use a letter to represent. And we're going to look at some of that later on. But if you look below, where after the word description, we have what is called a roster method. And the roster method, I think that was also discussed in the video, is where you list the members. So you could describe the members of a set, in this case, the set of days of the week, or you could use the roster method where you list out the days of the week. So in this case, they list it out, W equals, open bracket, and you use the curly brackets, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, close brackets. And they use commas to separate the elements of the set. And they use braces to enclose the elements of the set. So 2 methods are looked at here. One is the descriptive method, and the second is the roster method. So the descriptive method, you simply just write a phrase or a sentence to describe the members of the set. With the roster method, you actually list the members, but you put them in brackets and you name the set using a letter, a capital letter. That's your roster method. So we have first example here. Now in your book is American based, so you'll find a lot of the examples would be US based. So I changed this example because if you have the book, you will, I think they had some US names there for American presidents. So I changed it to our local situation. So I want, let me see, I'm gonna call on Dominic. It says, write a word description of the set. Dominic Fernando, if I ask you, what description could you give for this set?
Prime ministers.
Okay, now prime ministers, we have Mayor Motley, we have let me see, who else we have? We have PJ Patterson, we have the Jamaican Prime Minister was here the other day. What's his name again? Andrew Holness. You said prime ministers. You know that we could put more people in this set, but we only have 1, 2, 3, 4, 5. We have to put a description that when you mention that description, only those 5 names could come up. What else could you add to your description, Ms. Fernandez, to make sure that somebody else can put another name in the set?
What do you mean?
You see the names in the set?
Yeah, Pendleton,
Okay.
Ingram, Christie.
Okay.
Mm-hmm.
Menace Davis. So you said prime ministers, but what I'm saying to you, there are other prime ministers other than those. I could think of some
Okay,
other.
that's true. Bahamian, you mean? Oh, you mean? Okay.
So how could you describe the set further then? Let me hear what you said.
I would say Bahamian prime ministers or something
Okay,
like that.
Bahamian prime ministers. All right, so that's better. But there's still, we could, you know, in the future we could have Chester Cooper could be prime minister. What's his name? Michael Pintard could be prime minister. Sands could be prime minister. Fred Mitchell could be prime minister. So we still need to put a little bit more description in this to make sure only these names come up? What else could we add there to make sure only Pinlin, Ingram, Christie, Minnis, and Davis name comes up when we ask for this particular set?
Well,
Anybody else?
I
repeat
would
that?
say pass, but Davis is in it. So I don't know.
Okay.
I guess I'll send her for a lifeline. Somebody help me.
And anybody want to add to that? How else could we describe this set to ensure that only those names are put in this set?
Prime
Let me-
Ministers of the Bahamas from 1973 to 2020.
Okay. Well, 2020, no, when did Davis become prime minister?
Last year.
Last year,
Yeah, so you got,
2021, sorry,
okay, all
2021.
right, okay. So that could be a more descriptive way. So Prime Minister of the Bahamas from 1973 to 2021, you can't put any other name in this set. Only those persons would qualify to go in that set. So that's what we mean when we say a set must be clearly defined. So when you give a definition, it should be in such a way that anything else that you put in there would not fit. Okay, so if we put Cooper in that, it wouldn't fit because he was never prime minister, number one. But then even if he became prime minister in the future, then his time would be after 2021. So it's stable. Or we could even say the first 5 prime ministers of the Bahamas. The first 5 prime ministers would be those 5 names. Okay. Anybody else that comes after that would not be in the first 5. So that is what we mean when we say it must be clearly, okay, clearly defined. So there are more than one ways we could describe this set to make it clearly defined. So one way, the set of the first 5 prime ministers of the Bahamas, or we could specify the date, as someone else said. I didn't get the name of that person. Who gave the date range? What's your name?
Urbanet.
Urbanet. Okay, so as Urbanet said, we could also, another solution for that would be the set of Prime Minister of the Bahamas from 1973 to 2021. Okay, Mr. Pickstock, you clear on that? Mr. Pickstock? Oh, Mr. Pickstock on again. Okay, let me see. Miss Simon. Oh, Miss Simon is not here. Okay, Miss La Rochelle. Miss La Rochelle?
Yes, sir.
Yeah, are you clear on that and what we did so far
Yes,
regarding the definition?
I'm clear.
Okay, all right. So, okay, so we're gonna move on then. Oops, what I did. Okay, so in your book, you will see these checkpoints. So after each example that we go through, they have a checkpoint, which is something that helps to make sure that we understand the concept that was just looked at. So we were looking at describing sets. So checkpoint 1 says write a word description of the set. So you see the set there, L equals open brackets, A, comma, B, comma, C, comma, D, comma, E, comma, F, comma, close bracket. We want a word description for that set. So I give you a minute to think of it, and then I'm gonna call on Mr. Pickstock. Are you there?
Yes.
Yes, Mr. Pickstock. Mr. Pickstock, you weren't there when I called you just now. You see, that's one of the things I need. I need persons to stay focused on the class. So when I call your name, I should get a response. Okay, Mr. Pickstock, are you with us? Hello?
Yes, I can hear you.
Okay, yeah, but what I'm saying to you, when I call, I really want persons to be,
Yes, sir.
respond right away.
Yes, sir.
But checkpoint 1. Can you describe that in such a way that it clearly identifies what's in that set?
Okay, so it's gonna be a little hard for me because I don't have the book with me right now, but
You don't have the book, but you don't have to have the book. It's right on the screen.
okay, I see that. I see that.
Mhm.
So my question is, are we going based off of what we just did?
Could you repeat that?
Are we going based off of what we just did? Because we have like right set. So are we going over like are you A B C D E F? Are we going based off what we just did, or I'm writing a different set?
I want you to describe what is in that set.
Okay, so L equals C. I guess I don't know. Honestly, so I don't know. I'm trying.
Hmm? Yeah, but what do you see in the set?
Oh, okay, in the set I see letters. I see letters lifted in alphabetical order.
Okay. So what can you describe? How can you describe the set so that someone else who hears your description will only put those letters in the set?
Repeat that, please. Sorry.
Let's say you want to describe the set to someone, but you're not going to actually call the letters out. You're going to describe it in such a way that the person will only give you those letters.
I would say the set of the first 5 letters of the alphabet.
Okay, well,
6 letters
oh,
of the alphabet.
okay, all right, that's good. The set, and then there's one additional thing you need to say, but I think your description is good enough. You know that we have alphabets for different languages. You know, the Chinese have an alphabet, the Japanese have an alphabet, right?
So we would
So,
say
mhm.
the set of the first 6 alphabets of the English or something like that. would be-
Okay, the English language, right?
Yes.
So, so when you give your description of a set, you have to give it in such a way that it is clear. So anybody who hears this description will know exactly it's the set of the first 6 letters of the English alphabet. Okay, so anybody put anything else in there, that would be incorrect because it wouldn't be the set of the first 6 letters of the English alphabet. Thank you very much, Mr. Pickstock. All right, so we're going to move on now to example 2. Okay, so now we just did a description. Mr. Pickstock told us, describe that set for us, but we also looked at the roster method. With the roster method, we actually listed the members with the roster method. We list the members of a set. All right. So in this example, it says write using roster method. Set C is the set of US coins with a value less than $1. Okay. Ms. La Rochelle, what are the set of US coins with a value less than $1? Ms. La Rochelle, are you there?
I'm here.
Yeah. Which US coins are less than $1? What are the coins?
That'll be the penny,
Mm-hmm.
the nickel, the dime, the quarter. That should be it.
Okay, let's see what they have here. You missed
About
one.
$50.
The $50 is not that common, but they have a $50 also. Okay, so you see how the roster method is set up? It actually lists each of the items, and it's separated by commas, and it's enclosed in brackets. And the name of the set is C, so we put capital C outside. Okay, so that's how we would do the roster method. So Mr. Pickstock did the description. Now this is the roster method. So we're going to look at checkpoint 2. So it says set M is the set of months beginning with the letter A. Express this set using the roster method. So Ms. Nairn, tell me, how would you list this set? What's the solution?
So there isn't a month that begins with the letter E.
E? No,
A.
hold on.
You
There's no
said
month
A,
that
right?
yeah, begin with the letter A, yes.
Oh, yes. Oh, sorry, I forgot. Okay, so it'll be open bracket,
Mm-hmm.
April,
Mm-hmm.
close bracket.
You miss, it's more than 1 month.
Hold on. Oh, open bracket, April, August, close bracket.
Okay. What's supposed to be between the April and the August?
Oh, a comma.
Okay. What is the name of the set?
The name of the set is M.
Okay, so start over now and give me the full thing.
Okay, so it's M, open bracket, April.
No, before
Oh,
you get
sorry,
to open-
M
Mhm,
equals open
Mhm.
bracket,
mhm.
April, comma, August, close bracket.
Okay. Now I hope when we go through these examples and these checkpoints, persons are actually writing, because that also helps. So while that was Ms. Nairn who just responded. So Ms. Nairn, you could make notes, and the rest of you, it's good practice to, as we go through, write down, okay? It helps to reinforce that what was done, okay? Because a lot of times what we say, and within a minute or two, we're gonna forget. So it helps when you write down, you make notes. So it's in this checkpoint 2, set M is the set of months beginning with the letter A. You simply write down set M, you write the description, and then you write the answer. So that later on, when you go to review, you can, because I'm going to send this PowerPoint to you, but you won't see the answers for that checkpoint 2 in the PowerPoint that I send you. So in your review, if you make notes, then you could always look at your notes and compare to the PowerPoint. And when you make your notes for checkpoint, just put down on the side of it, checkpoint 2, and put your answer, so that when you look back at the PowerPoint, you could see what the answer for checkpoint 2 is. Because I'm just asking persons to say their answers. And so I want you to make notes as we go along. That helps you to remember. Okay? So Ms. Fernanda,
Yes,
did you make notes?
yes, I'm making notes.
Okay, all right, just checking. Okay, though. All right, so we're gonna
Um,
move on.
I don't mean to
Question.
interrupt, but I
Mhm.
actually, I'm doing what you told me not to do, because I
What's that?
actually had to go into work. I'm on the road.
Oh,
Yeah,
okay.
sorry. This will
Who
be
is
the
this
only
now?
time. Dominique Fernanda.
Oh, Ms. Fernanda.
I actually have to
Okay.
go into work, but this will be the only week that I'm doing this.
Okay
So
then.
I
So-
might have to leave early. I'm not sure. I'm trying to,
Okay.
but I'll watch the video to catch up.
Okay then. All right, Ms.
Okay.
Fernanda. So I'll know
Okay.
how to deal with this then. Okay then. Thank you. All right. So our next section, if you have the book, is on page 45. Something we refer to as set builder notation. Now that was also in the video that I sent to you, an explanation as to what we mean by set builder notation. So we looked at description, we looked at roster method. Now we're going to look at set builder notation. That's another way that you can describe or list as a set. And so you see here an example of how the set builder notation is done. it gives the name of the set, equal, open brackets, which means the set of, and then X, it says all elements X, and then you see that line there, such that, and then it gives a description of the set. So if I read it out fully, it should say set W is the set of, the brackets mean the set of, all elements X, such that X is a day of the week. So that's the language or terminology that we use to write set builder notation. So all they're asking you is for the days of the week, but they write it using set builder notation. All right, and you see two notes there. It says before the vertical line is the variable X, which represents an element in general. After the vertical line is the condition X must meet in order to be an element of the set. So the first X is just a general description of elements. And then this, after the vertical line, it actually tells you what the condition should be for X to be in that set. So once it's a day of the week, it's a member of that set. And so that's how set builder notation is set up. All right. So we have an example here now. It says converting from set builder to roster. So it says here, you have to express the set A is equal to the set of all X, such that X is a month that begins with the letter M. So they want you to put that in roster method, which means you're going to list the members of that set. So Miss Pratt, Irvinette Pratt, what are the members of this set? Miss Pratt?
Hi, I'm here.
Yes, what's the members of that set?
X is the set of
I just need you to tell me what
oh,
months would
sorry,
fall in
March
that
and
set.
May.
Okay. all
March and May.
right, Okay. Okay. So it's just March and May. So, of course, if you write it in set language, this is how you should write it. So you want to read that as it is, Ms. Pratt?
A equals, or A is the set of open bracket of all months.
No, just read what you see there. A equal.
A equals open brackets, March, comma, May, close bracket, close
Right.
braces, sorry.
Okay, all right. So that's how you would list it in roster method. So the description they gave
question.
us, yes, go ahead.
Okay, because I'm seeing the information you have on the screen was saying the X, such as X is the month that begins with a letter. So we don't have to write it like that. We just write it as this answer that you have here.
Okay, so we are looking at two things here. The one at the top where it says A equal X equal the set of all X such that X is a month that begins with the letter M. That is called set builder notation. And what they want you to do is to write the result of that using the roster method. So the answer at the bottom where it says A equals open brackets March, comma, May, close bracket, that is the roster method. So what you're doing,
they gave us in set builder method and they wanted in the roster notation.
Right. So all we are doing is converting from set builder to roster. And so when you give the roster, you just list out the members that belong to that set. You put them in brackets, separate them with commas, and you put the name of the set, which in this case is set A. You follow?
Yes.
Okay, all right. So we have checkpoint 3. So in this case, we're doing basically the same thing. It says express the set O is equal to the set of all x such that x is a positive odd number less than 10 using the roster method. So we're going to convert this from the set builder notation into the roster method. So let me see who I'm going to ask to answer that. Let me see. Krishna Kem. Hold on. Did I speak to you at all? Oh, she didn't show up. And Krishna, are you there?
I'm here. Good day. Good morning.
Good day. Good morning. Welcome. This is the first time you responded to me, right? I think.
Yes.
Yes. Okay. All right. Welcome. So are you following what we're doing so far? Can you answer this
Yes.
question?
Yeah.
Okay.
So it would be O equals open bracket 2, 4, 6, 8, 10 close bracket.
I could see you finish. I could see you finish high school a long time ago.
Why? Why you say that?
You got the positive. You got the odd and the even numbers mixed up.
It's a positive odd. It's a positive odd.
You gave me
Oh,
even numbers.
you want odd numbers. Sorry.
Okay.
So
All right. So
that would be.
go again. Mhm.
I'm so sorry.
No problem. No problem. That's how we learn, and that's how
So
we
we-
reinforce. Okay. So go at it again.
So it'll be O equals
Mhm.
open bracket 1,
Mhm.
3, 5,
Mhm.
7, and 9.
And
Close
then
bracket.
close brackets. Very good. Thank you.
I
All
read
right.
it wrong.
Yeah. No problem. So so we all should see that. So in when we do this in the roster method, we're going to just list the members in the set. We're going to call the set O equals open bracket, in this case 1, 3, 5, 7, 9. Miss La Rochelle. Miss La Rochelle? Hello, are you there? Fabian? Hello?
Yeah.
Okay, did you make notes on what we just did?
Yeah, I have a notebook here. He was talking about the odd and even like that.
Could you repeat that?
Yeah, I have my notebook here.
Okay, yeah. I just want to know if you're making notes. I check in with everyone every so often.
But
because
I
I
also
can't see.
book,
Hmm?
so I have the book, so I usually just highlight throughout the book.
Okay, okay then. All right. Okay, just checking. Thank you. Okay, so now, just a little note here I need you to be aware of. All right. Now it says here, no, I'm not going to say what it says. I want somebody to tell me what it says. Let me see. Miss Simon, are you there? Still not there. Okay, Miss Simon isn't there. Let me see who else. Let me
Yes, sir.
see. Miss Nairn.
Back.gov.bs, I believe.
I'm here.
Okay. Can you summarize what this note is saying? What are they saying here?
Okay, so they're basically saying that some sets are very long and
Mhm,
that we can shorten it
mhm.
by not listing all of the items, but using the dots. And ending with the last thing in the set and closing the bracket, the last
Okay.
element of the set. And
Yes. Okay. Very good. Very good. Okay. All right. That's Mr. Pickstock. Could you
sir.
mute until you're ready to respond? Because I'm hearing some feedback, I think, from you. Yeah. Okay. Okay. Thank you. Oh gosh, I lost track of who responded to me just now. That was
then
Miss Nairn. Okay. So Ms. Nan, yes, you are correct. Okay. So when sets are very long to list in the roster method, we can shorten it by listing a few of the elements and then using the 3 dots followed by a comma and then the last item in that set. And what do we call those 3 dots? Anybody want to say what it is? Because it's right there. What do we call those 3 dots? Hmm? I have to call a name then because nobody responded.
Ellipsis is a
Ellipsis. Okay, ellipsis. Ellipsis. All right. So the 3 dots we call ellipsis. Okay. Now look at these 2 sets that we have described here. And you're asked to say, what do they have in common? The set of all numbers less than 4, but greater than 10, and also greater than 10. And X is the set of all X such that X is a cow that speaks. So you're looking for numbers less than 4, but greater than 10. And you're looking for the set of cows that speak. What do those 2 sets have in common?
They don't exist.
Okay. All right. So you see the term there. We have no such set.
Can you
All
go
right.
back to that slide for me, please? I just want to make a note of that.
Okay. All right. So so the question was asked, what do those 2 sets have in common? Neither set actually have any members. And so sets that do not have any members, we refer to as the empty set. So a set that contains no elements is called an empty set. Okay. Another name for the empty set is the null set. Okay. So 2 terms we use for the set that's empty. And there are 2 ways we can represent it. You could represent it using the curly brackets with nothing inside of it, or we use the null symbol, which is like a 0 with a stroke across. Okay, so those are the 2 ways we could represent the empty set. Now, a lot of persons make this mistake where they put the null symbol inside of the brackets to represent the empty set. That's not the empty set. You're either going to put the curly brackets with nothing in it, or you're going to use that 0 with the stroke across, the slanting stroke, but you're not going to put that null symbol inside of the brackets, okay? Because that actually contains an element. It has 1 element in it, okay? So that's not the empty set. So the empty set or null set would be represented using either of those 2. So the first one is the empty set with nothing in it, or the null set, which is the 0 with that slanting stroke. All right, so the question is asked now, which of the following is the empty set? So the first one is a set with 0 in it. You see the response? It says no, that is not an empty set because it has 1 element. What is the element in that set?
0.
What is it? 0. Okay, so it has a set, an element, which is 0. The next one is just 0 by itself. And it says this is a number, not a set. It doesn't have, it's not in brackets, so it's not a set. That's just a number. The next one says the set of all x such that x is a number less than 4 or greater than 10. So, okay, so they're asking if it's okay. So we do have numbers. It says the set contains all the numbers that are either less than 4, such as 3, 2, 1, and so on, or greater than 10, which is 11, 12, 13, 14, 15, so on. So that's not an empty set because there are members of the set. Okay, so that wouldn't be empty. The last one says the set of all x such that x is a square with 3 sides. There are no square with 3 sides, so that would be an empty set. No square has 3 sides. So, okay. So, all right. So I have checkpoint 4. I want you to look at that, and I'm going to call on persons to tell me what they thought for those. So 4 of you will answer, but the first one says x is the set of all x such that x is a number less than 3 or greater than 5. The next one says x is the set of all x such that x is a number less than 3 and greater than 5. So the difference between them is the first one is saying or greater, the next one is saying and greater. And C is saying nothing, and D is brackets with the null symbol in. So I want to see which is the empty set. I'll give you a minute to reflect on that. You just need to write yes, no, and then I'll call on you to tell me what you have. Okay. Ms. Fernanda, are you still available? Okay, I guess she is not. Okay, Ms. Kemp, what you have for A?
I have no,
Okay, and why you say no?
because there's no, okay, there's numbers less than 3.
Uh-huh.
I'm
It says is a number less than 3 or greater than 5. So give me some numbers that could go in that set.
So less than 3 would be 0, 1, 2.
Mm-hmm.
And then greater than 5 would be 6, 7, 8, 9.
Okay. All right. So that is not an empty set because it has members. All right. So once you could put members in that set, then it's not an empty set. So thank you, Ms. Kemp. Ms. La Rochelle, what about B?
B, wouldn't B be the same answer as A because it's asking for both numbers less than 3 and greater than 5?
Okay, now, in the case of A, it could once a number is less than 3 or greater than 5, you could put it in the set. So 2, 8, right? Once it's less than 3 or greater than 5. But in this case, it's saying it must be less than 3 and greater than 5.
Oh, so it'll be an empty set.
Okay, because there's no number that is less than 3 that is also greater than 5. So that's an empty set. No number, any number that's less than 3 cannot be greater than 5. So, so that and the or makes a difference there. Even though the wording is similar, the fact that one says or, that means it could be one or the other. But when it says and, that means it has to fit both. You can't be less than 3 and greater than 5 at the same time. So that would be an empty set. Okay, thank you. Ms. Nairn, what you say about C?
C is not a set, it's just a word.
Okay, all right, thank you. Okay, Mr. Pickstock, what about D? Mr. Pickstock is no longer with us. Okay, so I have to mark him absent here. What time is it? 10:15. Okay, Ms. Pratt,
Hi.
okay, what you said for D?
Yes,
It's an empty set?
yes.
Why you say it's an empty set?
Let me see my notes. Because it's represented by the brackets or the line through the zero and close bracket.
Okay, for the empty set, it has to be one or the other.
Oh, okay.
So what you say?
Okay, so that'll be no then,
Okay, why no?
because it has to be represented by the open bracket, closed bracket with nothing in it, or the line through the zero.
Okay, so it's one or the other. How many members are in that set for D?
One.
One. It has a member, and the member is that 0 with the line through it. So it's not empty, it has something in it. Okay. All right. So thank you. We're going to move on then to notations for set membership. So you see that little E looking symbol? It says is used to indicate that an object is an element of a set. All right. So it replaces the phrase is an element of. So instead of writing out is an element of, we could just put that symbol there to represent as an element of. And of course, the opposite would be if it's not an element of, we put a slanting stroke through it to show that it is not an element of. Okay, so that's another symbol that we use in set language. Is an element of, or is a member of, and is not a member of, or is not an element of. So right here now, we have an example 5. They're asking you to use the symbols to determine whether each statement is true or false. So the first one says R is a member of the set of letters A, B, C to Z. Of course, we know that R is a letter in the alphabet, so therefore that is true. Okay. In the next one, 7 is not a member of the set 1, 2, 3, 4, 5, and we don't see a 7 in there. So therefore, that is also true. 7 is not a member of that set. So that is a true statement. And then the third one is saying that the set A is a member of the set A, B. And that's false because it's set A is a set. The first one is a set. The set containing A is a set, and the set A is not an element of the set AB. So A is a member of that set, but the set A is not a member. Okay, Are we all following that? That last one, C? Any questions with that? No? Ms. Pratt? Why is that false? What you understand from why did they say that's false?
Because A is the element. And hold on, are you statement is true or false? So it is false because it's saying that A is an element of a set A and B. So it's false because they only concerned about A.
Okay, so A, if they didn't have brackets around that A, then it would be a member of the set AB. But because they have brackets around the A, what does that mean when they put the brackets around the A?
That means that they only speaking about A because it's a closed
No,
bracket.
no, what does the brackets represent when we're dealing with sets? What does the brackets represent? It means that this is a set with a member A. All right, so that portion, that is actually a set that we're looking at. Are you able to see my cursor?
Yeah.
Okay, so you see this here, that is the set containing the member A. So if I did not have the brackets and just had A by itself, then that statement would be true because A is a member of this set AB. But because I have brackets around here, what I'm saying now that this here, bracket A, bracket, we don't have any such thing in this set. We only have the letter A and we have the letter B, but we don't have a open bracket A, close bracket within this set. Okay, we only have the letter A and the letter B. All right, so this is not a member of that set, and that's why that's considered false. All right, so let's go on now to a little tip here in relation to that same thing we just looked at. It says a set can be an element of another set. So in this case that we were just looking at, it says a set. So in C here, a set can be a member of another set. But in this case, this set is not in here because it doesn't have the A with the brackets within the set. So in this case, they're saying to you now, a set can be an element of another set. For example, you have this set here, and within the set, you have the set A, comma, B, close brackets, and then you have C. Okay, so that's a set with two elements. One element is the set AB, and the other element is the letter C. So even though you see three elements you see three letters in this set right here, really it's only two because this one is enclosed in brackets. So that's one element within this outer bracket. And then this C is the other element. So this is one element here and another element. Okay, so one element is the set AB and the other element is the letter C. Thus, AB, the set AB is a member of the set A, the set containing the set AB and C. And also C is a member of that set because C is right here by itself. So it's also a member. So in this other example, they didn't have the A contained within brackets here. They just had the A by itself. So therefore, that's why it's not considered a member. But if they had the A within brackets similar to this, then it would be true. All right. So you can have a set that's a member of another set once it's enclosed and the terms are enclosed in brackets. All right, so look at this checkpoint 5 and determine whether each of the following is true or false, and then I'll call on you to answer. Just write true or false next to each after you read it. Okay, Miss Nan,
Hi.
what you said A.
A is true because 8 is an element of numbers 1 through 10.
Thank you very much. All right. Okay, Miss Kemp, what you say about B?
B is true because R is an element of the alphabet. If that's R, right?
Yes. It's saying that R is not a member of the set A, B, C, and Z. Is that true or false?
Oh, that's false.
Why?
So the funny looking letter with the line through it, that means not.
Not an element of, right?
Okay. So that's false
Why you say false?
because R is an element of the letter of the alphabet.
But the set that they give us, is that listing all the members of the alphabet?
No, it's not.
What would they?
Okay, give me that question again, please.
Okay. What I want you to say to me, the set with A, B, C, and Z, how many members are in that set?
Oh, that's four. That's
Four.
four letters of the alphabet.
Right.
And it doesn't
Now-
have the continuation dots. So
Right. So if it had the continuation dots after C, how many members would be in that set?
all the letters of the alphabet.
And how much was that? You remember? How many
Is it
letters in that?
26?
26, right. So if it was A, B, C, comma, dot, comma, Z, then it would be all the letters of the alphabet. It would be the 26 letters. And in that case, R is a member. So it would be wrong to say R is not a member. But because this set only have 4 members, it doesn't have the continuation dots, it doesn't have the ellipsis. So it's only really A, B, C, and Z that belongs to that set. And they're saying to you that R is not a member of A, B, C, Z. Is that true or false?
That is true.
Right, it is true. R is not a member, okay?
Mhm.
So if they had said R is a member, then it would be false because R is not in the set. Thank you. Okay, Mr. Pickstock, are you there? Mr. Pickstock? Mr. Pickstock, can you unmute? Mr. Pickstock, I wonder if he's working today too. Oh boy, okay. All right, Miss, let me go, Miss Pratt.
Hi.
Okay, so what do you say about C?
C, is, okay, so I'm going based on the definition of what a set is, right? It's supposed to
Mhm.
be clearly defined.
Mm-hmm,
So it's saying that Monday is a set.
mm-hmm,
And then Monday is a set, is a day of the week. It is a day of the week, but you have other elements in that, so therefore that would be false.
Okay, the answer is false, but I am not sure if the explanation you give
Okay, so
Is
remembering
correct.
the definition that says a set has to be clearly defined.
Yeah, the set is clear defined because it says
Yeah,
X is a
so
day of the
Monday,
week.
right, so hold on, but the set in the first set, Monday, so Monday is the only element in that set. Whereas so they're saying is an element of is a day of the week. You have
Mhm,
other elements in that is a day of the week. Is what
mhm.
so
Okay.
I
What?
am not clear on that because Monday
Okay.
is the set.
Okay. There's something we could do with that Monday to make that statement true. Anybody want to say what could we do with that Monday to make that statement true? Anybody want to take a guess?
Remove the brackets, I guess.
Who is that now? Who is that?
This is Fernanda. I popped back in because I'm getting ready to leave.
Okay, Fernanda. Oh, you okay.
Yeah, I just got to.
Yeah.
Mhm,
That would be true. If you take the brackets out, then
mhm.
that would be true because Monday is a member of the set of days of the week. Because the days of the week, of course, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So Monday is a day, but because they put the Monday in brackets, what they're saying there is that the set Monday is a member of the set of day of the week. Is a day of the week. The set Monday is not in the set, but Monday by itself is a day of the week.
Right, so it'll be
Okay,
false.
so it is false. Yeah, it is false. Yeah, because they have the brackets around the Monday. If they didn't have the brackets around the Monday, it would be true.
Okay, so my
Okay,
explanation just was not.
right. Now let me see if my pen. Oh, my pen is working. So if this is if we had let me see, Monday. Okay, is a member. And if I had it like this, within the thing, I have Monday, comma, Tuesday, comma, let me say Wednesday. Oh, I forgot to put it right. Okay. And then the other bracket. So if I had it set up like this, asking you if the set Monday is a member of the set containing the set Monday, the set Tuesday, the set Wednesday, that would be true because each of these days are within curly brackets. And this one is also within curly brackets. So the fact that this is within curly brackets here would make this false because the days of the week are just Monday, Tuesday, Wednesday, Thursday, without the curly brackets. Okay, so you have to watch out for these brackets here. If the bracket is there and the bracket is not in the set itself for each of the members, then it wouldn't be identical. So let's move on then. All right, so one of the things we often make reference to when we're dealing with sets, because we often use them to describe sets, is the set of natural numbers. Another name for natural numbers is basically, I think, yeah, counting numbers. The set of counting numbers is also called the set of natural numbers. So those are numbers that we use every day, starting from 1, 2, 3, 4, 5. Those are your counting numbers. 0 is not in that, in the counting numbers. Okay, so numbers that we count with, we call counting numbers. Okay, and the symbol for counting numbers is N. And of course, because we can't list all the counting numbers, then we use the ellipsis to indicate that it goes on and on. All right, so the set of natural numbers, the numbers from 1 onwards, and we often use that when we are dealing with sets. So we have an example here where they ask you to express the following sets using the roster method. Set A is a set of natural numbers less than 5. So A equal 1, 2, 3, 4, less than 5. Set B is a set of natural numbers greater than or equal to 25. Okay, so in this case, B is equal to the set. It says greater than or equal to. So we start at 25 and we go up, but we can't list all of them. So after we list a few, we put the 3 dots to indicate that the pattern continues. Okay, so this one is using set builder notation. So this is the set E, is a set of all x such that x is a member of the set of natural numbers. Remember, n stands for natural numbers. So this n here means natural numbers. And so x is a member of the set of natural numbers and x is even. Okay, so we're just looking for all the even natural numbers. And so we list them, 2, 4, 6, 8, and we continue on and on. Okay, so that's some examples of dealing with sets using natural numbers. So I give you these 3 to consider. We're going to be using the set of natural numbers to list the members of these sets. And give you a minute to look at that, and then I'll call on you. But write your answers down. Mr. Pickstock, are you there?
Yes, I am.
Mr. Pickstock.
Yes, I am.
Mr. Pickstock.
Hello? Can you hear me?
You have to stay on target, Mr. Pickstock.
Pardon?
I've been calling you, and I haven't been getting any response. The only way we're gonna do well in this class, we have to stay focused. When I call on you, I expect a response. If you have to
Yes,
leave
sir.
for some reason, I need to know, but I can't. I really don't like teaching a class when at the end of the day, persons end up not doing well. And the main reason for that is not keeping up and staying focused when class is in session. Okay, so when I call on you, I expect a response. If you have to step out, put something in the chat so I can know.
Okay. Yes, sir.
I got no response. I want everybody in this class to pass. And the only way you're going to do that, you have to keep focused on the lesson. And when I call on you, I expect a response from you. Right,
Yes,
Mr.
sir.
Pickstock? Okay.
Yes, sir.
So I want you to answer the first question, A.
Set A is a set of natural numbers less than or equal to 3. So what the answer would be just 1. And would it be just 1?
Okay, so
1 and
set A is a set of natural numbers less than or equal to 3.
2. So would it be just 1 and open brackets 1, 2 close brackets?
It says less than or equal to 3. You miss it. You miss one number. Less than. What are the numbers less than 3?
Okay, sorry, 0. Open bracket
No,
0, 1.
no. Natural numbers don't include 0. It starts with 1.
Okay. So it's
So which ones are
would it
less
be
than
1?
3?
1 and 2 is less than 3.
Okay, and equal to 3. What's equal to 3?
6. 6 is equal to 3?
No, oh, yeah. No, which
Okay.
number is equal to 3?
So, okay, 1, 2, and 3.
Right. Okay, so give me the answer again then.
So it'll be A is equal to, A is the symbol, open bracket, 1,
Okay,
2,
you
and
say
3,
A.
close bracket.
Okay, so let me write it so we could I want you to explain it so I could write it down. So A equal, tell me what to write
Open
next.
bracket.
Open bracket, okay.
It'll be 1, 2,
Mhm.
and 3,
No,
close bracket.
hold on, you have to tell me what comes after the
1,
1.
1, comma,
Uh-huh.
2, comma,
Mm-hmm.
3, and close bracket.
Okay, thank you. Thank you, Mr. Pickstop. Okay. Let me see who else we have here. Okay, Ms. Camp, what you have for number 2? Ms. Camp, are you there? Camp. Ms. Camp, Ms. Camp. Okay. Pickstop. Okay, Ms. Nairn.
Hi. Okay,
Mhm.
so B is equal to 15, 16, 17, and dot, dot, dot.
Okay. So now I want you to say it in a way, I'm going to write it. I'm going to write what you say. So B
Is
equals,
equal to open bracket,
mhm,
15, comma,
mhm,
16, comma,
mhm, mhm,
17, comma, dot,
mhm.
dot, dot, close bracket.
Thank you very much. All right. Okay.
I have a question, please.
Go ahead.
Why aren't we putting the N before we open bracket? Because I'm really trying to list the natural numbers for set B.
Okay. Okay. So set B, the name of the set is B, and the numbers that belong to set B are from the set of natural numbers that are greater than 4. So that's just telling you where you're going to choose your numbers from. So you don't have to put N. What you need to put is the name of the set. All right. And once you put the name of the set, you open brackets and you choose from the set of natural numbers based on the description that they give you for that set. All right. So they're saying you can't put anything else from another set of numbers because you have the set of whole numbers. The set of whole numbers include 0. The set of integers include negative numbers. So basically that N or natural numbers is just telling you that you are to choose from the set of natural numbers to fill in that in the brackets. So you don't have to actually put the N there, but you are using the N or the natural numbers as your guideline as to which numbers you should choose from. Because if I told you now to include integers, then you would have to put negative numbers. So for A, if I say set A is a set of integers less than or equal to 3, you would have to go 3, 2, 1, 0, -1, -2, -3, and so on, because I told you to use integers. Okay? If I told you to use whole numbers, then for A, you would put 0, 1, 2, 3, because whole numbers include 0. Natural numbers do not include 0 and do not include negative numbers. Natural numbers go from 1, 2, 3 onwards. So, so the use of that term natural numbers is just telling you what set of numbers to choose from, but you don't have to put the N in your answer when you are listing it using the roster method. You understand me?
Yes, sir.
Okay, all right. So now for C, that was Miss Pratt. Tell me what C should be.
C should be, O is the set, so we put C equals,
Oh, sorry, I should put O. O is the O,
O is the
yeah.
set.
O equal, uh-huh.
And we're gonna put, so N, which will be the natural numbers, X is odd, so we're gonna put list the odd, all the odd natural numbers.
Okay, so we're gonna open brackets, and so what we're gonna start with?
1,
Mm-hmm,
3,
mm-hmm,
5,
mm-hmm.
7, and dot, dot, close bracket.
Okay, very good. All right. Thank you. All right. So right now, okay, I don't know if you want to stretch a little bit, because this one is a little bit more involved. So give you a minute to stretch, get up and stretch if you haven't done any movement. Give you 1 minute for that. Mm.
You have a few more minutes, Jamal. What you doing? Well,
Okay, I'm trying to make the screen a little bigger. So if you have the book, this is on page 49. And they're talking about inequality. And when the term inequality, that's when we're looking at the less than and greater than. The equal sign is equality. The less than and greater sign is inequality. So you're looking at inequality notation and sets. So in the first one, right here, this is what we're looking at now, number 1. X is less than A. The symbol for less than, right there. And so in the next column, we are looking at set builder notation, and they give you an example. The set of all X such that X is a member of the set of natural numbers and X is less than 4. And then the roster method actually tells you what members belong to that set. Okay. So in this case, X is less than 4. Since it's a natural number, it would be 1, 2, 3. Now, we're using the same scenario, but this time the symbol changed to less than or equal to. With that little dash under it, it means that it can be equal to or less than. So using the same notation here, but just changing the sign right here to less than or equal to, it says X, the set of all X such that X is a natural number and X is less than or equal to 4. Because it could be equal to 4, we're going to 1, 2, 3, and 4, because it could also be equal to 4. Now we're changing now from less than to greater than. The symbol for greater than is pointing to the right. X is greater than A. So if you have set builder notation, X such that all X is a member of the set of natural numbers and X is greater than 4. So using that same setup, X greater than 4, the members would be 5, 6, 7, 8 continuous. Now, when we have X is greater than or equal to, which is right here, if we say X is greater than or equal to 4, we have to include 4 in the result. So up here, we didn't include 4 because it says greater than 4, but here it says greater than or equal to 4. So that means 4 can be in the set because it could be equal to 4 as well. Okay, any questions so far with those? No? Okay, so we're gonna move on then to the next set. So all of what we looked at just now, the first 4, 1, 2, 3, 4, we were just looking at a single inequality sign. Now the last four, that's 5, 6, 7, and 8. We are looking at 2 signs, 2 inequality signs. So the variable is in the middle, X, the element. And so what they're saying here, if you read it going to the left, X is greater than A, but less than B. Okay, so in set builder notation, that means that the set of all X such that X is a natural number, X is greater than 4. Now it really should be 4 is less than X, but if 4 is less than X, it means that X is greater than 4. Okay, so 4 is less than X and X is less than 8, which means that X is greater than 4 but less than 8. And so the only numbers that would fit there would be 5, 6, 7, greater than 4 but less than 8. In this example in 6, they have the greater than or
Right,
equal
Mr.
to. Question?
Yes, the example that you went over just now.
Which one,
when
number
you-
5?
Yes,
Mhm.
because the symbol is less than, but you were saying that 4 should be greater than. I am not following
Okay.
that.
So very good question. Okay, so 4 is less than X and less than 8. So this part is not a problem. That's not a problem because X is less than 8. But here where it says 4 is less than X, give me a number that's less than 4 is less than what number? Give me an example. 4 is less than what?
4 is less than 5.
Okay, so 4 is less than 5. So X could be 5. All right, X could be 5. What other numbers X could be?
6, 7.
Okay, so anything above 5,
Mhm.
above 4. So if I put it like this, if I decide to switch it around, 5 in front and 4 here, can I still use this less than?
You would need to use the, yeah. Because
We
4
could
would
still
be
use
less
less
than
than. Can
5.
we say 5 is less than 4?
Oh, sorry, you need to use greater than.
We have to
5 would
switch it
be greater
around,
than.
right? So that's the same issue now. If you have 4 is less than X, if I want to know what X is, then I have to switch this around to this. If 4 is less than X, it means X is greater than 4.
Mm-hmm. Okay, so that's where we get
Okay.
the 5, 6, 7. Okay.
All right. So,
Okay.
so even though they have the 4 coming first right here, where I circle the 4, even though they have the, you notice how they have it when they read it, they have X is a natural number greater than 4 and less than 8. So they're looking at X is greater than 4 and less than 8. So they don't actually read it by saying 4 is less than X. X is greater than 4. All right. So you have to
Okay.
watch out for that. All right. So in example 6, it's the same basic principle, but this time they have the greater than or equal to, the less than or equal to. So X is greater than or equal to A. So again, you see, even though A comes first, they start with X because X is the element. X is the element, the member that we are looking at. And we want to now, if they say A is less than or equal to X, that means X have to be greater than or equal to A. So X is greater than or equal to A and less than or equal to B. So in the middle here, where we're dealing with the set builder notation, the set of all X such that X is a natural number and X is greater than or equal to 4 and less than or equal to 8. So since it could be equal to 4, we're going to start with 4 and we're going to go up because it has to be greater than 4 and it could be less than or equal to 8. It could be equal to 8. So we go 4, 5, 6, 7, 8. All right. And then 7 and 8, using the same basic principle, but all they did is one of them is less than or equal to or greater than or equal to, and the other one is just less than or greater than. So in number 7, we have the set of all X such that X is a natural number, X is greater than or equal to 4, but X is less than 8. Greater than or equal to 4, that means it could include 4, but it can't include 8 because it's less than 8. So that's why we just have 4, 5, 6, 7. And then in the last one, 8, X is a natural number such that X is greater than 4, but less than or equal to 8. So it can't include 4 because it has to be greater than 4, but less than or equal to 8. So it could include 8. Okay. Any questions with that? All right. So this is one of those things that a little practice will help, but that is the inequality notation with sets. So let's move on then. We're going to look at a couple of examples here. So in the first one, it says representing sets of natural numbers, express each of the following sets using the roster method. So in the first one, let me see now. I think I've been doing too much talking. Let me see. Miss Krishna, Cam, you could read that first one, A. Read what it says.
So it says X
The
is
set of all X, okay, the set of all X such that X is a natural number and X is, read it like that. Go ahead, Ms. Cam.
such as X is the natural number and X is less than or equal to 100.
Okay, all right. So you see why that solution they give you, you understand the solution that was given? Does that make sense? Ms. Cam?
Yeah, because it's saying that you have they want the natural numbers, but it has to be equal to or less than 100.
Okay, so
add all the
100,
numbers.
so 100 have to be in that. Now, why they have those 3 dots there?
Because it's the ellipsis. They keep going on to 100. Did I
Okay,
pronounce that word properly?
ellipsis.
Ellipsis, okay.
Mhm. So why we put that ellipsis there?
Because it's a lot of numbers going. So just to continue the numbers.
Okay, so instead of writing out all those numbers, we could shorten it by just putting the ellipsis to indicate that it continues on and on until we get to 100. Thank you very much, Ms. Kemp. Ms. La Rochelle.
That's why I
Hi.
Okay, Ms. La Rochelle, I want you to read B. Read what it says.
X is a set of number and 70 is.
Ms. La Rochelle, you have to
Yes.
start
yeah.
over. Listen to what I'm going to say. The set of all X such that X is a natural number and so on. Start it like that.
The set of all X, such as X, is a natural number and 70 is less than or greater to X. Greater
Less
than
than or say that again. 70 is
70 is less than or greater to X.
less than or equal to X.
Less than or equal to X. Less
Mhm.
than 100.
Okay. Now, normally when we're reading it with the two inequality symbols, we start with the X. So if 70 is less than or equal to X, if I start with X, what should I say?
X is greater than or equal to 70.
Mhm. And X is also,
Less than 100.
okay, I want to start over now, brand new, and say it again. The set of all X such that
Set of
X
all
is,
X.
mhm.
Sorry, repeat that again.
The set of all X such that,
The set of all X such that X is greater than.
no, X is a member of the set of natural numbers. You missed that part.
The set of all X
Mhm.
is a set of natural numbers and X is greater than or equal to 70 but less than 100.
Okay. I think I need y'all to write this down because okay, so I'm gonna put the answer. Now, Miss La Rochelle, you see why the answer is there? Tell me if it looks right to you. and
Yeah,
why
I
it's there.
understand the answer. It's just wording it.
Okay, so I'm gonna put this here. The set of all X such that X is a natural number and X is greater than or equal to 70 and X is less than 100. Okay. So the set of all X, this line here means such that X is a natural number because it says here X is a member of the set of natural numbers and X is greater than or equal to, because we're starting with the X. If we were starting with 70, we say 70 is less than or equal to X, but we normally start with the X. So X is greater than or equal to 70 and X is less than 100. You follow that, Miss La Rochelle?
Yes, I'm writing it down.
Okay. So I suggest all of you write it down so you know it helps to kind of reinforce how you should read when you have the two inequality symbols involved in your your question. Okay, Joel Pickstock, can you go over that, please? What time that was? 10:50. Mr. Pickstock, are you still with us?
Yes, I am.
Yeah, I see where you had put something in the chat, but you could just interrupt whenever I'm speaking to ask, for me to go over something. I prefer if we do that because sometimes I don't check the chat as regularly, but I see where you have something in the chat. But are you still needed explanation with that, or Mr. Pixar? Hello? Mr. Pixar?
I'm sorry, I got it. Thank you.
Okay, all right. All right, I guess all of you should be through making a note with that description, so I'm going to move on then. Okay. Oops. Oh, wow. Okay. I'm gonna have to erase that because I have the next checkpoint there. So let me see how we're gonna do that. Okay. Okay. I think I made a little boo-boo. So I'm going to have to write that on the side. Let's pages that again.
Page 50.
Page 50. Okay, thank you. All right, so checkpoint 7. They want you to give this in raster method. So the first one, oops. Okay, so, all right, so we have it here now. So you could do those two. So the first one says X, the set of all X, such that X is a natural number, X is less than 200. And the next one says the set of all X, such that X is a natural number, and X is greater than 50, but less than or equal to 200. Okay, so okay, Mr. Pickstock, are you there?
Yes.
Okay, could you answer A for me, please?
8 is, the answer to A is a set of elements. 1, 2, 3, 4. Open bracket. 1, comma, 2, comma, 3, comma, 4, comma, and 5, comma. What the ellipsis? Am I pronouncing it right?
Ellipsis, yes. Mhm.
Yes, ellipsis. Then we put a comma. 200. No. Is that right? 200.
It says less than 200.
100. Oh, okay. So it's, let me see, because okay, so it's the set of numbers. Open brackets. You have 1, 2, 3, 4, 5.
Mhm.
Um,
So ellipsis.
could we
Mhm.
do it where? Could we do it where as by I could put like the ellipsis on 200?
You see, it doesn't include 200 because it says less than 200.
Oh, so less than 200. Okay, so
Yeah.
we'll put um less than 200.
Yeah, what number is less
So
than
would it be
200?
what? So would it be like 199?
199. Very good. That's it.
Yes.
Thank you. Okay, Ms. Kemp. What about B?
So I'm gonna try it. So it's open bracket, 50, 51, 52.
Okay, it says greater than 50.
So that'll be 51. You'll start from 51.
Okay. Mhm.
152, 53, ellipsis, comma,
Mhm.
ellipsis.
Mhm.
And so it's greater than,
We're going.
it'll be 200. Lowest bracket.
Okay, thank you. All right. So the first one says less than 200, so we couldn't include the 200. But in the second one, it says less than or equal to 200. So you could include the 200 in that one because it could be equal to 200. All right. Thank you very much. So we can move on then to the cardinality of a set. So the cardinality of a set is a big word, simply just to mean the number of members in a set. So the cardinal number of set A, and it's represented using n of A. So if the set is A, the cardinal number is represented using n of A, and that is the number of distinct elements in a set. And when we say distinct because you can't repeat. If you repeat, then you don't count it twice. So the symbol n of A is read n of A. Repeating the elements in a set neither adds elements to nor changes its cardinality. Let's look at an example. Okay, so you're asked to find the cardinal number of set. How many members are in this set? Because since you have your mic open, tell me how many members in that set. Set A. Mr. Victor?
Yes, there are 4 elements in the set.
Okay, so there are 4 elements in that set. So we would say the cardinal number or the n of A equals 4. That's how we'd write it. Okay. Miss La Rochelle, how many members are in this set B?
It's 0. Wouldn't that be an element? Wouldn't that be a set because it's just 0?
How many members are in the set?
1.
1. You sound out like you're not sure. It's only 1 member in the set. Yes. So the number of members in set B equal 1. You write it as N, open bracket, B, close bracket, equal 1. N of B equal 1. All right, let me see now. That was Miss La Rochelle. Miss Kemp, how many members in set C?
Mm. $11. So that's NC equal to 11.
Okay. So even though you don't actually see 11, the ellipses indicate that it continues from 13 to 23. So you have to count all those missing ones. So you would say N of C, the number of members of set C, is equal to 11. Okay, thank you. Okay, Ms. Nairn, how many members in that set?
0.
Okay, very good. That's the empty set. So number of members in the empty set is equal to 0. All right. Give you a minute or two to answer those. Write your answers down, and then I'll call on you. Tell me what you have. Okay, Ms. Pratt, what you have for A?
I have N A equals to 5.
Thank you. All right. Hey, Mr. Pickstock, what you have for B?
N B equals 8.
For B? How many members?
Oh,
in
sorry,
set?
I look at it wrong.
Mhm.
I think okay. My first answer would be my suggestion is one.
I didn't hear your answer for B.
Okay, my first initial answer would be 3, but then my suggestion, because what it could it be, because it don't have no commas, would it be 1?
The answer is 1. That's the reason why we put commas, so we could identify each member separately. So this is just one number, 872. Yeah. Miss, okay. Miss Nairn, what you have for C?
8.
8. Thank you. And okay, Miss Kemp, what you have for D?
That's not a set, it's an empty set.
So how many members in the set?
None.
So the answer should be 0.
But there's
Okay.
0 with the line through it.
No, just 0.
So just
Just
0?
0.
Okay.
Yeah. 0 with the
So why are
line
we not
through it.
putting a line through it? Why are we not putting a line through it? If it's
Yeah.
Because
empty set?
0 with the line through it is another way for naming the empty set. So I could
Oh.
have put D equals that, or I could have put D equals that. It means
Okay.
empty set. But if I ask you how many members are in a set, you need to give me a number.
Okay.
Anytime you see n of that, is either 0, 1, 2, 3, 4, 5, whatever, a number must be given. All right, but that symbol is not a number, it's just, that's another way of saying the empty set.
Okay.
Okay, all right. Okay. So now we're going now to equivalent sets, page 50. Page 50. Yeah, starts at page 50, going on to 51. So it says here, set A is equivalent to set B if set A and set B contains the same number of elements. For equivalent sets, n of A is equal to n of B. So in this example that they give you, we have set A is equal to set of all x, such that x is a vowel, and the vowels we have are A, E, I, O, U, 5 members. Then we have another set B, the set of all x, such that x is a natural number, and x is greater than or equal to 3 and less than or equal to 7. So that's 3, 4, 5, 6, 7. The two sets do not have the same members, but they have the same number of members. Both of them have 5 members. So because they both have 5 members, they are considered to be equivalent. Okay, so that's different from being equal. Two sets that have equal members, the same members, are considered to be equal sets. But two sets that have the same number of members are considered to be equivalent. They don't have to have the same members once they have the same number of members. Okay, so they mention here to line with arrowheads. So you see these lines here with arrowheads right along here. It says, indicate that each element in set A can be paired with exactly one element in set B, and each element in set B can be paired exactly with one element in set A. So you could match up A with 3, E with 4, I with 5, O with 6, U with 7. It doesn't necessarily have to be A with 3. It could be A with 4, but then E with 3. Once you can do a one-to-one matching, it means that they have the same number of members. Okay, so that's your equivalent sets. Now, okay, so that's just what we spoke about just now. So if you can do a one-to-one matching, like what we just did here with these arrowheads, then you have equivalent sets. The number of members in one set is equal to the number of members in the other. But if you cannot do that, then you put here that the number of members in A is not equal to the number of members in B. If they don't have the same one-to-one matching, if you can't match one for one, then they are not equivalent. And we're going to look at an example here. Okay, now those people with the book, my example is a little different from what's in the book. The book have a different example for this example 9. Okay, so here it's giving you a table, and it says the table shows the celebrities who hosted NBC Saturday Night Live most frequently and the number of times each starred on the show. A equals the set of the 5 most frequent hosts, and B, the set of number of times each host starred on the show. And the question is asked, are these equivalent? So these would be the members of set A, the persons who hosted the show, and the number of times they hosted the show is shown here in set B. Now, I want you to note, we could match Steve Martin, 14, Alec Baldwin, 12. Now you see John Goodman, he's 12 also. We have 12 appearing twice here. Buck Henry, 10. Chevy Chase, 9. Okay, so technically in set A, how many members do we have?
5.
5. So N of A equals 5. How many members do we have in B?
Or
equal 4, right? So if a member is repeated, you don't count it twice when you're dealing with sets, okay? So anything that's repeated is only counted once. So right away here, because the number of members in these sets are not the same, then they cannot be considered equivalent, all right? They are not equivalent. So this is the explanation here. Okay, so the first method they use is trying to set up a one-to-one correspondence. So you see Martin is 14, Baldwin and Goldman are both 12, Henry is 10, Chase is, so therefore we do not write the 12 twice. We only want to know how many distinct members in the set. So because we can't do an exact one-to-one, the sets are not equivalent. Okay, so the next method they use is to count the members in the set. The number of members in set A is 5. The number of members in set B is 4. So because they do not contain the same number of elements, then they are not equivalent. So we could either look at trying to match them like this, using the arrowheads, or we could just count the number of members in the set. If they are not equal, then the sets are not equivalent. All right, so we want to look at this, this diagram for checkpoint 9. Let me see, I think that's the same thing in the book for those who have the book. Yeah, okay. So in checkpoint 9, they have a graph where they're saying that in most societies, women say they prefer to marry men who are older than themselves. Okay, so women want to marry men which are older than themselves, okay. Whereas men say they prefer to women who are younger. Figure 2.1 shows the preferred age difference in a mate in 5 selected countries. All right, so you see the scale here, that's showing women, and this here is showing men. So the green is what's reflected for women, and the years older than self they prefer. And then at the bottom is men, and it's showing the years younger than self they prefer. All right, so let me ask a question now. Looking at this graph, which country have the highest age difference for women? Which country has the highest age difference for women? Just want to see if you
Would
are
it be
following the graph.
Colombia?
Colombia, very good, thank you. Colombia have the highest age difference for women. So what they're trying to say there is that among these 5 countries, Colombian women have the highest age difference. They prefer men 4.5 years older than them. Now, looking at the same graph, which country have the lowest age difference for men?
The United States.
United States. Okay, so men in the United States seem to prefer women much closer to their age than the other countries in the graph. So what this exercise is asking you to do now in checkpoint 9, they're saying to you, A is the set of 5 countries shown in figure 2.1. So the 5 countries. So how many countries? So set A would have how many members? N of A equals what?
5.
5.
5.
5 countries: Zambia, Colombia, Poland, Italy, United States. Now, set B, N of B, it says set B is a set of average number of years men in each of these countries prefer women who are younger than themselves. So we're looking at the men, okay? So the yellow represents men. So what is the number for men?
Would it be
Would it be
2?
2? Okay. Zambia is 7.3. Colombia is 4.5. Poland is 2.8. Italy is 2.8. United States is 1.9. How
Or
many members? Okay, it's 4. Because why you say 4?
because 2 countries have the same rating of 2.8.
Right. So the number of members in set B is actually equal to 4. Okay, so there are not 5 distinct numbers in that set for B. It's actually only 4 because we have a repeat with Poland and Italy. So are those 2 sets equivalent?
Yes.
Yes. Why
Oh,
you say
sorry,
yes?
no.
Why
You're
you
talking
say no?
about A and B?
Right, right.
Oh, no, they're not
Yeah.
equivalent because they don't have the same amount of number.
Okay, because they don't have the same amount of members. One have 5 members and one have 4. So they are not equivalent. For 2 sets to be equivalent, they must have the same number of members. Okay, so let's move on then. Okay, so now here we have a few more definitions. Finite set. A set A is a finite set if the number of members in A is equal to 0. That means it's an empty set. Or the number of members in A is a natural number. Move on. Infinite set. A set whose cardinality is not 0 or a natural number. The set of natural numbers is assigned the infinite cardinal number, which is read Aleph null. Now you don't have to really study that. You don't have to memorize this, but it says here, I need you to know the set of natural numbers is assigned an infinite cardinal number. So what they're saying to you is that the set of natural numbers is infinite. So if you ask whether or not it's finite or infinite, you know it's infinite. Why is it infinite? The set of natural numbers. Anybody?
Because O is not a natural number.
How many natural numbers do we have? What's the first natural number?
1.
One.
What's the last natural number?
9.
9?
No, that's
it says indefinite, so wouldn't there be no
indefinite.
infinite? Sorry,
So
wouldn't
we
be no
could go
ending. I'm sorry.
trillions, quadrillions, septillions. We could count on and on and on and on and on and on. There's no end to the set of natural numbers. We definitely know it starts with 1, but we don't know where it ends. So because there's not a number to represent that, then we say that that is an infinite set, okay? Sets that you could actually represent with a number is finite. So the empty set is finite because you could represent it with 0. Okay? The set of the number of hair on your head, is that finite or infinite? The number of strands of hair on your head, was that a finite set or infinite set? Nobody want to take a guess on that?
Finite.
Finite. Why you say finite?
Because if you sit down to count them, you would have an end. You would be able to say what is the end number you come to.
Okay, very good. So even though it may take a long time to actually do it, it might be tedious or difficult, there's a point where you will eventually be able to count the amount. Okay, so even though something may seem like a very large amount, once you can eventually count the amount, okay, then it's finite. Now, in cases where it's impossible because there is no end, like in this case of natural numbers, then we have what is called an infinite set. And then the last thing we need to look at here is equal sets. Set A is equal to set B if set A and B contain exactly the same elements. Okay, so if they have the same elements, now we're not looking at the count, we're looking at what's in the set. Okay, of course, if the two sets are equal, it means they also have to be equivalent, because if two sets are equal, they must have the same amount of members. So equal sets are equivalent, but equivalent sets don't have to be equal. Equivalent sets just have the same number of members, but they don't have to have the same members. But all equal sets are also equivalent, because in order for two sets to be equal, they must have the same number of members. Okay, so let's look at example 10. Determine whether each statement is true or false. So look at A. It says 4, 8, the set containing 489 is equal to the set 894. True or false? Are those two sets equal in A?
Equal.
Yes.
Equal. Yeah,
True.
they are equal because they have the same members. Are they equivalent?
Yes.
Yes.
Yes, they are equivalent. So once it's equal, it's also equivalent. Okay, look at the next one. B. Are those two sets equal?
No,
No.
No.
Well,
Okay, why not? Why are they not equal?
because there's a 0 in the second.
Okay,
Bracket.
there's a 0 in the second one. Are they equivalent?
Yes.
Yes.
Yeah. Why you say they're equivalent?
Because they have the same. Yeah, I believe they're natural numbers and they're the same.
What makes sets equivalent? For sets to be equivalent, they have to have the same number of members. Do they have the same number of members?
No,
No.
What's the difference? One have,
0.
Zero.
no, number of members.
One
Oh,
of
One
4
of three and
and one
one
of
of
3.
four.
One have 4 members and one have 3 members. So they are not equivalent because they do not have the same number of members. They are not equal because they don't have the same members. Okay, one have 135 and one have 0, 135. So one have a 0, which the other one doesn't have the 0. So they're not equal. And they're not equivalent because one have 3 members and the other one have 4 members. Okay. All right, so let's look at this checkpoint 10 and see. A. Is that true or false?
True.
True.
Okay, they are equal. B, true or false?
False.
False. Okay. All right. All right, so we are now moving on to section 2.2. So we're on the last leg. It's a lot to cover. That's why I say you have to try and come to every class, because if you miss a class, you miss a lot. You're going to miss a lot. It's a sacrifice that you decide to take up. So you have to spend the time to it. I know some of you, you know, you pay a good sum for this. So please make sure you put in the time so you can benefit from it, so you don't end up wasting your money. Okay? Once you come to class, you ask your questions, you do your work, you will do well. But if you miss out, then you will have a challenge. Okay? So You see what it's like at the beginning, so make up your mind now. Every class I'm gonna be here. I'm gonna try and do the work. I'm gonna follow. And if I have questions, I'm gonna ask questions because I don't want to waste my funds, my investment, my time. And I will do my best to assist you. Once you ask questions, you could stop me anytime in the lesson if you have a question and ask your question. I'll try my best to respond to you in a way that helps you to understand. Okay, so let's move on to this last little section, which deals with subsets, which is on page 57 of your book. All right, so now a subset, set A is a subset of B, and the symbol for subset, you see it written there, is written, A is a subset of B. This is the symbol right there. It's almost like a sort of C with a line under it. It's a subset. If every element in A is also an element of B. Okay, so if everything in one set is also in the other set, the first set is a subset of the second set. That's what we mean by subset. Okay, and so, of course, if every element in A is not in B, then we have the symbol. We just put a slanting stroke across it to say it's not a subset. Okay, so now this last thing here says every set is a subset of itself because every set contains every member of itself. So every set is a subset of itself. Okay, so let's look at this here. So they ask you, say, write is a subset of or is not a subset of in each blank to form a true statement. So what do y'all think about this one? 1, 3, 5, 7, 1, 3, 5, 7, 9, 11. Is A a subset of B?
Yes.
Yes, A is a subset of B because everything in A can be found in B. Okay, so it says here the solution, all elements of A are also contained in B. Therefore, A is a subset of B. Okay, I'm going to continue with example 1 and look at this one. A is equal to the set of all X such that X is a letter in the word proof. B is equal to the set of all Y such that Y is a letter in the word roof. Is A a subset of B?
No,
Why no?
because A has more elements than B.
Okay. So what element is in A that's not in B?
P.
P. Okay. So now if I had reversed it and say, is B a subset of A, would that be true?
Yes.
Yes.
Yes. Yes. Okay. All right. So the solution here. So they ask you to write out the letters of A or the members of A. So the members of A would be P, R, O, and F. O appears twice, so we don't need to write it twice. On B, you have R, O, and F. O appears twice, so you don't need to write it twice. Okay? So because there's an element in A that is not in B, then set A is not a subset of B. So that's how you would write that one. A is not a subset of B because everything in A is not in B. But in this case, if we had it reversed, where we would ask if B is a subset of A, then that would be true because everything in B is in A. Okay. So we have one more in this. So now let's see. Now say A is equal to the set of all X such that X is a planet of Earth's solar system. Anybody remember how many planets we have? No? Okay. I don't see Pluto, so I think it's supposed to be 9. Okay. Let's see what they have here. All right. So they ask if A is, oh, okay, I see what happened here. They're saying A is equal to the set of all X, such that X is a planet of Earth's solar system. So it says all the elements of A are A is equal, okay, and B is equal to Mercury, Venus, Mars, Jupiter, Saturn, and Neptune. Because all the elements of set A are also in set B, A is a subset of B, okay? Furthermore, the sets are equal. I wonder if this is correct. Let me see, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Example 1. Oh, okay. Okay, I see. I was wondering about Pluto, but if you have the book on page 57, apparently they are saying that there are 8 planets. Now, we did not forget Pluto. In 2006, based on the requirement that a planet must dominate its own orbit, Pluto is slave to Neptune's orbit. The International Astronomical Union removed Pluto from the list of planets and decreed that it belongs to a new category of heavenly bodies and is called a dwarf planet. Okay, that's interesting. All right, so in that case, then they only are looking at 8 planets in this case, and since the 2 sets have the same members, apart from the one being a subset of the other, they are also equal. Okay, so Pluto is not considered a planet anymore, it seems, according to this textbook. All right, so let's look at these 3. And you're going to write, is a subset of or not a subset of. So I'm going to just call on persons to tell me what they think. Natanya, there, the first one, is A subset of B?
No, A is not a subset of B.
Okay, so right away we could see that that is not so, because not everything in A can be found in B. All right. Ms. Kemp, is A subset of B?
Yeah, because you could find roof in proof.
Okay, you could find all the members of the set in A, R, O, and F in the set B, P, R, O, and F. Yes, so it is a subset, yes. Okay, C, let me see now. That was, okay, Mr. Pickstock. Is A subset of B? Mr. Pickstock? Ms. Pratt, are you there? Is A subset of B? Okay.
Yes,
Is
A is a subset of B.
Okay. All right. So A is a subset of B. And in this case, A is also equal to B. Why?
Because all of the members in subset A is equal to all the members in subset B.
Well, we wouldn't say subset. All the members of set A are also
Equal to all the members in B.
right. Okay, thank you. Now, in the book, in the set language, we have what is called a proper set, subset. Okay, so we have a subset. So the subset, what we just look at, we have the symbol with a little dash under. With a proper subset, we don't have that little dash under it. Okay, so that little dash under means that it could also be equal to the set. In the case of a proper subset, it says set A is a proper subset of set B, and written with this symbol here, A is a subset of B. If the set A is a subset of B, and set A and B are not equal. Okay, so a set is not a proper subset of itself. For it to be a proper subset, they cannot have the same number of members. Okay, so let's look at this example here. It says write subset or proper subset or both in the blank to form a true statement. All right, so here it says X, the set of all X such that X is a person that lives in San Francisco. B is equal to the set of all X such that X is a person that lives in California. Okay, so of course, San Francisco is a city in California. So is this a proper subset?
Yeah.
Yes, because definitely the number of persons that live in San Francisco would be a smaller number than the number of persons that live in California. Those two sets cannot be equal. So it is a proper subset as well as it is a subset. So the two symbols could work there because A is a subset of B. Everybody who lives in San Francisco lives in California. And it's also a proper subset because the size of the set A is definitely smaller than set B. The two cannot be equal. So both symbols would apply. Let's look at this other one. Which symbol would apply here? Is this a proper subset? Is this a proper subset? Oh, let me see. Fabian, La Rochelle, is this a proper subset? What you said?
You're asking if B is a proper subset?
If A is a proper subset of B.
No,
Why not?
it says X, it says it's a person and X lives in San Francisco and the
No,
other one.
I'm finished with that one. We are now on B.
No, it's not a sorry, it is a subset of B. It includes all the elements and 2, 4, 6, and 8 is included in there.
Okay, so what I'm saying, A is a subset of B, but is it a proper subset? That's what I want to know. It is true that A is a subset of B, but I also want to know if it's a proper subset. Remember now, a proper subset cannot be equal to the other set. If it's a proper subset, it cannot be equal. So is it a proper subset?
No, it's
No.
not a proper subset.
Why?
They're equal.
They're
They're
equal.
equal.
Right. So it cannot be a proper subset. So the symbol, only one symbol would fit in this particular case, and that's the one for subset. So in B, question B right here, the two sets are equal. They have the same members, 2, 4, 6, 8. Just B is arranged a little differently. So because they have the same members, A is actually a subset of B. But you cannot use the proper subset symbol, which is just this by itself, because for it to be a proper subset, A has to have less members than B. Okay, so if all the members in A are found in B, but A have less members than B, then A is a proper subset. Okay, so okay, I think I can let you read that on your own. It's in your book, and it will be on the PowerPoint when I send it to you, because we're kind of pressed for time. But I want you to look at these two. Let's look at these two now. So you could either use subset or proper subset. Okay, so this one here just means subset. And of course, this one means proper subset. And the subset means everything in the first one can be found in the second one. Proper subset means the same thing, but they cannot be equal. The first one have to have less members than the second one. So let's look at this first one, A. Okay, so which symbol would we use? Can we use subset and proper subset, or just one of them?
Proper
We can-
subset.
Proper subset. Okay. Now, if it's a proper subset, it's also a subset. All right. So the two symbols could be used there for that one, but 2A, the two symbols. Okay. It is a proper subset, and it's a subset as well. Okay, look at B.
Proper subset.
Proper subset.
It's a proper subset. Okay. So B would the two symbols will also work with B as well, because it is a proper subset as well as a subset. So the only time it wouldn't be a proper subset is if the two sets are equal. But neither of these, we have the two sets equal. Okay. All right, so moving on. Now, this here is dealing with the empty set as a subset. For any set B, the empty set is a subset of B. That's what this is actually saying right here. So for any set that you look at, the empty set is a subset of that set. Another way people say that is that this empty set is a subset of every set other than itself. Okay, so in this case, it's right here. For any set B other than the empty set, the empty set is a proper subset. Okay, so you can't have a set being a proper subset them being equal. So the empty set cannot be a proper subset of itself, but it's a proper subset of any other set. So let's look at this example here. So if A is equal to the empty set and B is equal to 1, 2, 3, 4, 5, is A a subset of B? Yes or no?
No.
No.
No? What is set A?
An empty set.
Okay. And you see this first one here, number 1? What is that saying? What does that mean in English? Number one.
So B has no set, an empty set, and it's a subset of B.
Okay, that's Irvinet.
Yes.
Okay, read it as it's stated there. Read it.
For any set B,
Mhm.
empty set is a subset of B.
Okay. What do you understand by that? Convert it to regular English and let me hear what you think it means.
Okay, so any set that we have,
Mhm,
B is
mhm.
an empty set and is a subset of B.
Hold on a minute. Yes, sir. Uh-huh. What? I'm not finished yet. Oh, okay then. All right. Okay, sir. All right. Okay. All right. Oh boy, I gonna have to end the lesson because apparently they need this for another class. So sorry about that. Now what I gonna have to do is, let me see. The answers are here, so I'm gonna have to skip through because the girl just called to say they need the thing for another class. So the answers are here. And if you have any issues, and then, oh gosh, I didn't do this part here, but you could read through it and follow through. We were just almost at the end. And then check, okay, your homework questions are right here. Homework page 53, but I have the questions here already. So if you don't have the book, you could just go right through that. And then the answers are at the back. Okay, homework questions for 2.1, 2.2. Okay, so you have two sets of homework for 2.1 and 2.2. So this is 2.1, page 53, and these are the numbers of the questions. Continue here, continue there, and then 2.2, these are the numbers of the questions, and I have the questions listed here. And then you could check your answers at the back, and then next week, if you have not sure about anything, then you could let me know, and we could discuss it. The latter part that we didn't cover, if you have any questions, you could always send me a message on the number that I have there, and I could try to explain it to you as best as I can. And that's it. Sorry about that abrupt end, but I didn't realize the time had flown that quickly, and they need the Zoom class for another group. All right, so thank you very much for your attention, and I'm going to email the presentation to you, and so you could get the homework questions and so on, and the rest of the presentation from that, and we will meet again next week Saturday at 9 o'clock. Okay, so bye-bye.
Have a good one.
Okay then.